Hey guys, welcome back to my channel. Today let's talk about expected value of a binary variable. Okay, expected value of binary variable. You can take today's video as a good preparation for the next video, which is maximum likelihood estimator. Okay, I already filmed all the videos. I just need to edit a little bit and upload it online. Okay, so when the variable is binary variable, that means it can take only two values, 1 or 0. How do you solve for expected value of this variable? Or more importantly, how do you understand or interpret this expected value? Okay, so without further ado, let's get into the video. Okay, let's talk about expected value of a binary variable. Y is a binary variable, can take on two values, 1 or 0. So it could be 1 or 0, that's the value of y. Right? The value is y, values that y can take on. And then we have the probability that y equals 1, suppose it's p, and the probability y equals 0, which is 1 minus p, because y can only take on two values, right? The probability y is 1 is p, and then the probability y is 0 is 1 minus p. And now look at the expected value of y. If you learn probability theory, you probably know that. So this expected value of y equals the value of y times probability plus the value of y, which is 0, times probability, or that equals sum the value of y times probability that y equals the value. So I equals 0, 1, right? And then that equals p plus 0 times any value 0, so that equals p. So now the expected value of y equals p. And we know that p is probability y is 1. So you can write that equals probability y is 1. Let me write a different way. So y can take on two values, 1, 0. And the probability that y is 1, you can just write probability y is 1. This is y sub I. Right? Probability y is 0 is 1 minus probability that y equals 1. So now expected value is average y equals 1 times probability that y equals 1 plus 0 times probability that y equals 0. And that equals 1 times probability that y is 1 plus 0 times 1 minus probability that y is 1. So this whole thing is 0. So that equals probability y is 1. Again, if y is binary, the expected value of y is just probability y is 1. Okay, so let me write it here. So if y is binary, expected value of y is just equals probability that y is 1. So now with this in mind, you can understand the linear probability model or Logit Probit model. So we have this I, 1, 2, 3, 4, 5, 6, and y is binary. 1, 1, 0, 1, 0, 0, like this. And x could be continuous. x1, x2, x3, x4, x5, like this. And now you draw the scatter plot, y, x, and we know y can only take on two values. Right? It could be 0, 1, and I suppose, right? So that's a scatter plot. That's what scatter plot look like. And then if you use linear probability model, you just draw a line through these points, right? Draw a line through these points. If you use Probit model or Logit model, it'd be like this, right? Probit or Logit model is like this. You interpret this regression, right? So if linear probability model, so that's linear probability model. So you have this predicted value of y, which is expected value of y given a value of x. And because y is binary, so that equals probability that y is 1 given a value of x. It's kind of the key to understand the interpretation of regression with a binary dependent variable. So that equals b0 plus b1x. Okay, for any value of x, let's suppose for any value of x, if x equals this much, for example, this is x1, and then you plug that into this equation, you solve for a y, maybe 0.78. And this, interpret this as 78 0.78 is a probability that y is 1. So that's 78% probability that y equals 1, given x equals x1. Maybe y is whether to buy a house, whether to go to college, and x is a family income. So given family income this much, the probability to go to college is 78%, or the probability of buying a house is 78%. Same thing for a Probit or Logit model. This pink curve, so any point along this pink curve is predicted value of y. And we know that equals expected value of y given a value of x. And because y is binary, so expected value of y equals probability that y is 1 given a value of x. If there's a Probit model, that equals phi, right? So that's phi is cumulative standard normal distribution functional form, phi of b0 plus b1x. So for any value of x, maybe x, x2, you plug that into this equation, you solve for probability that a y is 1. Maybe here is 0.6. So now you interpret this as when family income is equals x2, and the 60% chance that you buy a house, right? That's how we interpret that. The probability that y is 1, maybe y equals 1, buy a house, 0, not buy a house, right? Go to college, not go to college. So we interpret this expected value as the probability that y is 1 given a value of x. The probability that I'm going to college given a value of family income. Okay, this is how we understand the expected value of a binary variable, or expected value of binary dependent variable. How do you interpret this linear probability model and Probit Logit model? I hope you find today's video helpful. Any questions, let me know. And the next video is about the maximum likelihood estimator, so stay tuned. See you next time. Bye.